Hello, welcome to today's lesson where we're going to look at the equations of motion. So we're going to try and calculate the motion an object would experience under constant acceleration and work out values of that motion. So today's lesson sits in the GCSE Combined Science topic of forces in the physics course. So what we're going to look at in today's lesson is we're going to try and look and state the differences in the equations of motion found for objects, calculate values based on the equations of motion, and then finally explain the conditions needed to be assumed when the equations of motion are used. So it's going to focus on the following part of the specification. So we're looking at the acceleration part of the specification for GCSE Combined Science Physics, and in particular we're really going to focus on this particular equation. Final velocity squared minus initial velocity squared equals 2 times by acceleration times by distance. So let's just have a think about this. When considering the motion of a fallen object, what factors or what quantities can be measured by experimenters? What could we use in a mathematical equation to detail the motion of an object fallen? Well, we can actually measure the following 5 particular quantities. Displacement, which is given the symbol s and measured in meters. The initial or starting velocity, given the symbol u and measured in meters per second. The final the final velocity or the ending velocity, which is given the symbol v, which again is measured in meters per second. Acceleration of the object, which is given the symbol a, which is meters per second squared. And finally, the time taken for the motion, which is given the symbol t, and the units are in seconds. Now we can place these different measurable factors into different equations to fully describe the motion of an object. Now we call these equations the equations of motion or the Suvat equations. We call them the Suvat equations because the symbols can be arranged to spell the word Suvat. Now basically we can use these equations to work out the values of an object moving when an object has constant acceleration. You can also call it uniform acceleration because in this context uniform and constant mean the same thing. Now the most common example of constant acceleration is when an object is falling freely under gravity. So if you take any object like a ball, like a parcel, like a person, and you drop them freely, okay, they will have constant acceleration under the concept of gravity. Now near the Earth's surface, any object falling freely under gravity has an acceleration of 9.8 meters per second, which will come across before because that is the strength of gravity. So the gravitational field strength and the gravitational acceleration are actually the same concept because gravity causes an acceleration. So other examples of uniform acceleration could be a plane taking off, a train pulling out of a station, or a car on a motorway. Now there are 2 equations of motion which you've got to be able to use in GCSE physics. And these, as I said before, are termed the Suvat equations due to the possible terms that can be found in these equations. S displacement, u initial velocity, v final velocity, a acceleration, and t time. Now remember, S in this particular concept stands for displacement, not speed. D would stand for distance travelled, but remember, distance travelled and displacement are not the same concept because displacement is a vector, it has a direction, it is the straight line distance from the start of the journey to the end of the journey, whilst distance travelled is a scalar, it's just the overall amount of length moved by an object in a journey. Now, just to clarify, there are 2 equations of motion which you will be able to use in GCSE physics. There are 2 further equations of motion which are only covered in A-level physics. So if you look in certain textbooks, you'll see 4 equations of motion, but you only need to be aware of 2 for GCSE physics. Now, the first equation is an equation you've seen a number of times before. Acceleration is equal to final velocity minus initial velocity over time. Now we can pop our units in, so velocity is measured in meters per second, time is measured in seconds, and acceleration is measured in meters per second squared. Now we can put this into a symbol form like we mentioned before, so A equals V minus U over T. Now this equation has to be memorized for your examination. You've got to learn this equation for your exam. Now the second equation is that final velocity squared minus initial velocity squared equals 2 times by acceleration times by displacement. So again, let's pop our units in. So we've got our acceleration is measured in meters per second squared. We've got our displacement in meters, and any velocity squares will be meters squared over seconds squared. Now we can write this in symbol form. V squared minus u squared equals 2as. Now this equation doesn't have to be memorized for your examination because it is given to you in your exam book. So unlike that first equation, you are actually given this particular equation. But you will probably, if you are on doing a higher level paper, have to rearrange this equation to work out values in question. So you might need to work out acceleration or displacement or final velocity or initial velocity. So you'll have to do some work with the equation to get only one symbol by itself on one side of the equation to work out that particular value. So let's just clarify. The Suvat equations, or the equations of motion, can be used to work out values for an object moving when the object has constant acceleration. So if the value of acceleration was changing, you can't use these Suvat equations. Now, the first equation is acceleration equals final velocity minus initial velocity over time, which you see sometimes written as acceleration equals the change in velocity divided by the time. And the equation, the second equation, equation 2, is final velocity squared minus initial velocity squared equals 2 times by acceleration times by displacement. Now, our assumption, like we said before, in these equations is that the acceleration stays constant throughout the journey. Now, the most common example of uniform or constant acceleration is free fall and due to gravity, where acceleration, or g, is always 9.8 meters per second. Now, in examination questions, it's common for you to work out the acceleration and then be used to work out the resultant force that causes the acceleration, which can be done because we know from Newton's laws of physics, the second law, F equals ma. So if you have the acceleration and you have the mass of the object, you can work out the resultant force that causes the acceleration. Now, to answer equations of motion questions correctly, you've got to do the following steps. Step 1. Write out the variables which are known in the question. So you take the numbers from the question and you rewrite them out. Step 2. Select the correct motion equation. Now, you know which is the correct motion equation because there should only be one unknown variable in the equation that you've chosen. Step 3. Place the numbers into the equation and make sure the units are in the correct form. So kilometers become meters, centimeters become meters, minutes become seconds. Then simplify and rearrange the equation as needed. It is my advice that you pop the numbers in first and then start to rearrange, because you get a mark in your examination for recognizing the symbols or the values with the correct quantities. Okay, then step 4, calculate the answer, put into the correct units with the correct number of significant figures, and then step 5, remember the assumption that this can only occur when the acceleration is constant with a non-zero velocity. So that's a very, very, very important idea. Now, let's look at a particular example of this. So, a student investigates terminal velocity by dropping balls of modeling clay in a liquid. For a particular ball, she makes the following measurements. The initial velocity is equal to 0.035 meters per second. The final velocity equals 0.013 meters per second. The distance over which the velocity changes is 0.30 meters per second. So what's the average acceleration of the ball during this journey? Well, first step, you write out the variables that are known in the question. So S, U, V, A, and T. So I've wrote down that I know what S is, the displacement, which is 0.30, the starting or initial velocity, 0.035 meters per second, the final velocity, 0.013 meters per second. We don't know acceleration, but we want it, and we don't know the time. So we select the correct equation. Now, the correct equation here is v squared minus u squared equals 2as, because you need just one unknown variable, which is a, and it needs to be a because that's what you're working out. So you can't use the other equation because that also includes t, and you don't know t. Then what you do is you pop your numbers in, so you substitute all your values in, and then you work out each side. It's my advice that you work out each side first, and then you simplify and rearrange the equation needed. Because if you look on, for example, on the left-hand side, v squared minus u squared. Well, if you try to just rearrange the symbols, you can quite easily make a mistake. But if you get the value for v, you get the value for u, you square both terms and subtract them, it then just becomes one number, minus 0.122331. And therefore it's very easy then to then rearrange that number because it's only one term as opposed to two. And the same on the other side. So 2 times by a times by 0.30 simplifies to be 0.6. So we now know that minus 0.122331 equals 0.6a. So a then equals minus 0.122331 divided by 0.6. So step 4, work out your answer, minus 0.203885. Now we haven't got any units on this and we haven't put it to the correct number of significant figures. So if we look in the question, the initial velocity, 2 sig figs. The final velocity, 2 sig figs. The distance over which the velocity changes, 2 sig figs. Remember, you start counting the number of significant figures after the first non-zero number. So there are two non-zero numbers after the first one. So 351330. So there's 2 sig figs. So you give your answer to 2 sig figs. So the answer is acceleration equals minus 0.20 meters per second squared. And we'll stick our unit on there. Now the last one is, remember our assumption that this acceleration is constant. Now it's a negative number. What does that mean? That the object is decelerating, it's slowing down. So if that makes sense, because if you look at that, the initial velocity is higher than the final velocity. Let's look at another question. A van is traveling at 23 meters per second and it starts decelerating uniformly at 2.0 meters per second squared as it heads towards a built-up area 112 meters away. What will its speed be when it reaches the built-up area? So let's write out our values, S, U, V, A, and T. We don't know V and we need it. We don't know T. We know S is 112. We know U is 23. Now, importantly, we know acceleration is minus 2 because it's decelerating. So we put a negative sign to represent decelerating. That it's going to be slowing down. So we then select the correct equation. Once again, T is an unknown variable, so you can't use that first equation because then you have two unknown variables in your equation. You pop your numbers in, and again, what do? You simplify both sides and then you rearrange because it's a lot easier to rearrange it once you simplify the numbers. So we're doing v squared minus 23 squared equals 2 times by minus 2 times by 12. So the right-hand side becomes minus 448, and then the left-hand side becomes v squared minus 529. So you take 529 to minus 529 to the other side becomes plus 529. So v squared equals 81. So therefore v equals 9 because we're square rooted 81. Now the issue is how we wrote it the correct number of significant figures and how we wrote it with the correct units. Now you might say, well, look, there's 3 sig figs in 112, but 2 sig figs in 23 and 2.0. Well, you go with the lower number. So because 2 of them are 2 and 1 of them is 3 sig figs, you go with 2 sig figs. So the answer is the final velocity v is 9.0 meters per second. And remember that this can only occur when the acceleration is constant. So one last example question. We'll do it all at once this time. So a driver of a vehicle traveling at a speed of 30 meters per second on a motorway brakes sharply to a standstill in a distance of 100 meters. Calculate the deceleration. So what do? Well, you write out what information you know in the correct question in the correct units. You find the correct equation. There should only be one unknown. Place the values in the question and work it through. And give your answer to the correct and significant figures in the unit. And remember, because we've worked out a negative acceleration, that means it must be decelerating. It must be slowing down. Now again, it's always nice when you're doing your calculations to make the equal signs line up because it makes your working out easier to follow. So, if we have learnt in today's lesson, well, in previous lessons we've looked at the concept of acceleration and how it links into velocity time graphs and how we can also use displacement time graphs to work out values, and then we can use this following equation. Okay, so v squared minus u squared equals 2as, where v is the final velocity, u is the initial or starting velocity, A is a uniform acceleration, and D is the displacement or distance in meters. So if we've learned in today's lesson, we can state the basic equations of motion, we can calculate values of objects based on the equations of motion, and we can explain the conditions you require when we use the equations of motion. Thank you very much, and hope you've enjoyed today's lesson on the equations of motion.